Now, in this problem, the hemisphere is submerged in the liquid as shown in the figure. So, you have to find the force on the lower half of the hemisphere. Lower half means this. Let me color it red. This is the lower half of the hemisphere. So, the force on the lower half of the hemisphere, that is the quarter sphere actually. So, liquid applied force from the side on the vertical face, and also liquid applied force due to pressure normally on the surface. And you know that this force, say Fx, and so this force is also Fx, because see, as you know, when water applied force on a submerged body, then the sideways force, they will cancel each other. Because as you know, see, any submerged body in a liquid, net force will be upward. That's what buoyant force is. However, this Fx, this is Fx, and that this, I mean, Fx means for the left side, it is the x component of the net force on this curved surface. And for the right side, Fx is actually the net force on this flat surface. That is having only the x component, so no y component as such. So that means ultimately you have to find out this Fy. That means the so Fy, that means y force, vertical force on this lower half of the hemisphere. Now, what we can do is actually, suppose there were a sphere like this. Say if you had a full sphere like this. So if you calculate the net vertical force on this lower half of the full sphere, this would be 2Fy, right? So as it is Fy on each quarter sphere, so Fy plus Fy would be 2Fy. Now, what we can do is that, so this 2Fy, I mean, I am telling it for the sphere, 2Fy minus the force on the top surface of the sphere. Force on the top surface of the sphere is actually the weight of the liquid, the weight of the water on top of the sphere, right? So, see, if you see the top surface, you see this is, so I am drawing the top surface like this, right? So, the volume of water on the top surface is equal to, see, this is a cylinder, height r, radius r. This cylinder minus, from this cylinder you have to subtract this much volume, right? So we can calculate force from the top, say write it Fy prime. So 2Fy minus Fy prime is equal to buoyant force on the sphere. Buoyant force is equal to 4/3 pi r cube rho g. Now this Fy prime, from this diagram you can write Fy prime is nothing but weight of this much liquid on top of this hemisphere. So let us calculate the volume. It is pi r square into h, that means the height of the cylinder is h, minus 2/3 pi r cube times rho g, that is Fy prime is equal to 1/3 pi r cube rho g. So now let us get here. So twice Fy is equal to 4/3 pi r cube rho g plus Fy dash, that is 1/3 pi r cube rho g. So that means 2Fy is equal to 5/3 pi r cube rho g, implies Fy is equal to 5/6 pi r cube rho g. So there is an option, and that's j cap also. So this option is correct. That is option A, 5/6 pi r cube rho g j cap, as the force is vertically upwards.